Today I'm going to talk about how zkVerify is going to market. This is going to be for a general audience. I'm going to talk about what the opportunity in the space is for the zero-knowledge proof verifications, and it's for a general audience. I'm Rolf Versluis. I'm the Director of Business Development at Horizon Labs. Our team is going out and talking to all sorts of other projects about integrating zkVerify into their ecosystem. So we're going to go over why ZK now, what's changed that it's all of a sudden so exciting in this space, what zkVerify does, and what type of applications and systems it enables. So I'll draw a nice little diagram and step y'all through this. How it works with other ecosystems. So pretty straightforward, designed to be composable and modular and work with all sorts of other ecosystems out there. And I'll give examples of what we're doing regarding that. And then how the zkVerify team is going to market. So we're going to talk about specific things that we're doing, the opportunity space within zero-knowledge proofs in the short term and the long term, and how we're looking to address it. One thing I can tell you is I'm not going to spend this entire time talking about ZK rollups and aggregation. This is going to be about completely different stuff. Before I explain how zkVerify works, I'm going to talk about just basics of what you can do with the zero-knowledge proof. First of all, I don't really fully understand this because it's advanced cryptographic math. So I know on Horizon Labs, we got a great team of cryptographers and software developers that can implement this cryptography into reliable software. I just have to go out and talk to people about it. But the way that I understand it is we have public inputs, we have a series of computation, and then we have a result of those computations. Now this information is fed into a ZK proof creation algorithm, and that's run on some kind of computing system. So basically, this goes through and uses the cryptography of the public inputs, the computation, and the results, and creates a zero-knowledge proof. Now, creating the proof is great because you can prove that these computations were done correctly without sharing the computations. So all you have to do is share the public input and the results and the zero-knowledge proof. So how do we verify this? Okay, well, the verification, which is just as important as the proof creation, is done by having the inputs to the computation, the results to the computation, and the proof all sent to the verifier. And this math is set up so that a lot of the calculation, a lot of the work gets done in the ZK proof creation, and the ZK proof verification doesn't take as much computation, so it can be done quickly. So anyway, you get these three inputs to it, and you get an answer. Either it verifies that the ZK proof was correct, and it proves that these computations are correct as a base of these results, or it's false. So that's big picture what you can do. So any type of system where you want to prove that a computation was done properly, or that the underlying information is valid, lends itself to ZK proofs. And longer term, this is going to allow Web 2 applications to work with each other over public Web 3 because ZK proofs are able to prove the inputs from the Web 2 to the Web 3 applications and also prove that the computations were done. We can talk a little bit more about that in detail, but the big idea is that we're going to be able to come up with entirely new ways of communicating, doing finance, and doing all sorts of other types of transactional activity, or even just activity between people and groups of people using cryptography to verify that things are done properly.